Let's see the other concept, moment of inertia for ring. So I have a ring. Okay, so here this will be the axis of rotation. So this is the center of it, center of axis of rotation. So now from this it is going to rotate in this direction, moment of inertia is there. Okay, so the radius of this ring is r. At this particular point the total mass of the ring is capital M. Okay, the total length of the ring is L. L means length of the ring, that is 2 pi r. Okay, it's a 2 pi r. Now here in this, what is the formula for moment of inertia? To find I equal to integral x square dm. Okay, this is the basic formula to find the moment of inertia. Here mass is there, length we know, and we are about to take this particular element. The particular element of mass is dm, and thus that thickness dx. Okay, right. So dm and dx. Now mass per unit length equal to change in mass per that small element dx. Okay, from this dm will be equal to m by l. L is how much? 2 pi r into dx. Okay, 2 pi r into dx. So now I am going to replace this dm in this equation. So what we will get? What we'll get, we'll see here. I equal to integral x is what here? X is nothing but r. Okay, so r square dm. So I equal to integral r square. So from where to where integration? From 0 to r. Okay, 0 to r. So r square dm is this, the one, m by 2 pi r into dx. Here r gets cancelled. Then I equal to m constant, 2 pi constant. So taken out m by 2 pi integral 0 to r d dx is nothing but here r dr, or you can take as dx, no problem, r dr, both are same only. Okay, then I equal to m by 2 pi. So here let it be x itself. Here r is a constant, right? R is also constant only, no radius, so it's also taken out. So integral 0 to r dx. Integral dx is nothing but x m r by 2 pi of x of 0 to r, that is nothing but m r by 2 pi of x. X is what? 2 pi r. 2 pi r, that is the length. Okay, so 2 pi gets cancelled, it is m r square. So ring, everywhere the ring is radius is r only. Okay, so from it is always moves from 0 to r, that length is r. R means here total length, that is m r square. Okay, clear, right? So moment of inertia for a ring is m r square. Clear now? Next, so what is the moment of inertia for disk? We are about to do now disk. So I have a disk, so like a plate. Okay, so from this, here will be the center of axis of rotation, there is a center of mass. Okay, let's consider origin point. Now this total mass is m, and it have area, that area is a. So what is the area of this plate? It is pi r square. Let's consider this radius is r, so pi r square. Now we are about to consider small element. Let's consider a small element of ring, like a ring. So this thickness is dx. Okay, and the length from here to here is smaller. Let's consider smaller. Okay, and that mass is, that particular mass is dm. Okay, dm dx, and let it be r or x. Okay, let it be x, no problem, as we have considered dx, so let it be x itself. Okay, now if you will cut this part alone, then it is also like a ring only, no, right? So dm by d a area, that small element dx, but dm by dA equal to m by a. So dm equal to m by area. What is the area? Area is pi r square into this dA will be written as x dx or L dx. What is the length? Total length of this circumference of the circle, that is 2 pi r. So dm equal to m by pi r square into 2 pi 2 pi x only, it's not r, because this is the one circle we are considering, that circle radius is x, so 2 pi x dx. Okay, pi gets cancelled, so dm equal to m by r 2x dx. Okay, now this is going to be substituted in well known formula, that is I equal to x square dm. So moment of inertia I equal to integral from where to where? 0 to r, some part, right? 0 to r, 0 to r x square. Okay, x square into dm. Dm is, this is the one. What is that? M by r 2x dx. So here which is constant? M by r into 2. So I equal to 2m by r is a constant, integral x cube dx. Okay, so sorry, here it is r square, so it is r square, it is also r square, x cube dx from 0 to r. Then it will be I equal to 2m by r square of 2m by r square of x power 4 by 4 for integration, then 0 to r. Then I equal to 2m by r square of r power 4 by 4, upper limit minus lower limit. So 2 ones, 2 2's, r square, here 2 gets cancelled, I equal to m r square by 2. Okay, this is the moment of inertia for disk. Okay, clear? Next, moment of inertia for rod. So rod already we discussed, right? Now it is for, let's consider CD, disk. Okay, how the CD will be? So this is the one outside and this is the one inside. So here what is there inside? This is empty space, just center of mass. Okay, so this distance let's consider as r2 and this consider as r1. So two radiuses, r1 and r2, two distances. Okay, right. So from this, what will be the dm? Dm equal to m by area. What is the area? Pi r2 square minus pi r1 square. Pi r2 square minus pi r1 square. Okay, into length into dx. So dm equal to m by, if you'll take pi common, r2 square, it's a capital R. Capital R only consider, no? R2 square minus r1 square into length. What is the length? Length is circumference of the circle. 2 pi 2 pi x dx. We are considering some element at, consider some this point or from this end at this point, dm dx. Okay, 2 pi x dx. Pi gets cancelled. What is the value of dm? Dm equal to 2m by r2 square minus r1 square into x dx. What is the basic formula? I equal to integral x square dm. So I equal to integral x square dm is 2m by r2 square minus r1 square x dx. So x into x, x cube. So from integral, from where to where integral? R1 to R2. From here to here only, no? I mean from here to here, this is one. So from R1 to R2 limits. So 2m constant, right? So can I write outside? 2m by R2 square minus R1 square. That is the I. Okay. So remaining x square into x. So it is an x cube dx. So I equal to 2m by r2 square minus r1 square of x power 3 means that is x power 4 by 4 whole power r1 to r2. So I equal to 2m by r2 square minus r1 square into 4 will be taken common, upper limit minus lower limit. Upper limit is r2 power 4 minus r1 power 4. So this will be written as moment of inertia I equal to, here 2 ones, 2 2's gets cancelled. Okay, so 2 will be taken out. So m by 2 into, here r2 square minus r1 square into r2 power 4 minus r1 power 4. So can I write it as, this will be written as r1 square minus r2 square whole square. Okay, got it? Like a power 4 minus b power 4 it is. How will be written as a square minus b square into a square plus b square. So if you will write like that, then that will be r2 square minus r1 square into r2 square plus r1 square by 2 into r2 square minus r1 square. So both will get cancelled. Then I equal to m of r1 square plus r2 square by 2. So this is the moment of inertia for for a CD disc. Okay, CD, like a CD. Okay, clear? Right.